Alright, so I'm going to show you guys how to create a feedback loop using the Draw.io software. This is also going to give you an example of a negative feedback loop to give you an idea of what your feedback loops may look like, or at least to give you kind of like a starting point. So this feedback loop is going to look at PTH regulation of blood calcium. So there's my title. PTH, if you don't remember from your notes, is parathyroid hormone. So what I'm going to do, I'm going to start with a box, and if you use the software, you can just double click into the box to type some text. But when we're doing a feedback loop, it's good to just start with homeostasis, and remember that's just the kind of the baseline, or where our body wants to be with its values and levels and all that stuff. So I'm just going to type out homeostasis, and in this case that would be normal blood calcium levels. I'll say this just so you don't get confused. PTH regulates blood calcium, but calcitonin, which is one of the hormones you will do a feedback loop for, also regulates blood calcium, but in a different way. So don't think that this one's going to be the exact same and you just swap out PTH for calcitonin, because calcitonin actually works in the opposite way that PTH works. So I start with my homeostasis box. I'll just kind of move that out of the way. Then from there, and if you look at the assignment, it also gives you guidelines. So I'm going to make sure that this feedback loop fits with those guidelines. So the first thing was a title, which I have. Then I need a box for homeostasis, so I have that. So the next thing that we need to see is some type of stimulus. So something that occurs that is going to create some type of change in the body. So you don't necessarily have to label like stimulus, change, all that, but I'm going to just so you can have that visual. So my stimulus, and the stimulus does need to be specific, not just like blood calcium decreases. That's the change. You need something that would make or cause blood calcium levels to drop. So for my example, or for my stimulus for this feedback loop, I'm going to say that this individual has prolonged use of the acid reducer omeprazole, and then I just click there to there to connect those. Okay. There's a couple ways you can connect these, I'm pretty sure. Like I can just put in like a diagonal arrow if you like that better. Which the formatting, I'm not going to like format this one super beautifully, but you are more than welcome to. Okay, so there's my stimulus. Prolonged use of acid reducer omeprazole. Now, I didn't just randomly know that prolonged use of omeprazole causes a decrease in blood calcium levels. I researched that, so you can research a stimulus that would work for your feedback loop. So after the stimulus, we have a change in the body. So in this case, that would be a decrease in blood calcium levels, and that change takes us, or how to word it, that change takes us away from homeostasis, or where we want to be. So this is where negative feedback comes in. So the body's reaction to the stimulus is going to counteract the initial change, because if our blood calcium levels decrease, we want something to occur that's going to increase those levels so we can go back to normal. So in this feedback loop, the sensor gland is the parathyroid gland. The sensor gland will not always be the only gland involved. In this case, the parathyroid gland is the only gland that we're going to see in this loop. In the insulin signaling pathway, the pancreas is really the only gland. But in the two that you are going to create, you may have more than one gland in a feedback loop, and that is fine. That's actually how it should be. So, the sensor gland, like I said in this case, the parathyroid gland detects the change in blood calcium levels. Again, you can format yours super nicely if you want. There's all kinds of stuff you can do. I mean, you can change colors, you can make your lines look really cool. I think I have like a 15-minute time limit with this little screen recorder, so if I have time, I will make mine look nice and pretty. Okay, so I have the sensor gland. The parathyroid gland detects the change in blood calcium levels. So from there, the output, and you'll have several like outputs. There's not just one output typically in these feedback loops. The output from the parathyroid gland, the parathyroid, really I should say parathyroid gland since there's 4 of them, release parathyroid hormone, and that is PTH. That's the abbreviation for that one. I'm going to change this to say glands. Oh, no, I want the nice diagonal line. Ooh. There we go. Okay, the new box. So from there, this one gets a little, not messy, but it's going to have a couple branches at this point because parathyroid hormone goes to 2 different places. So, one target, I'll just call it target 1, parathyroid, let's just go with PTH. PTH, how do I word it? PTH will travel through the blood bone cells called osteoclasts. Again, this information was not in the notes, it's extra, so I just researched this. So PTH travels through the bloodstream and will interact with bone cells called osteoclasts. So target 1 would be bone, and target 2 would be the kidney. So PTH travels through the bloodstream to the kidney. And from here, a couple things are going to happen. There's one, and then now it does actually matter where your arrows point, because this is a cycle that moves in a specific direction, like it wouldn't move backwards. So it does matter that the arrows point in the right direction. So PTH travels through the bloodstream and interacts with bone cells. And then PTH travels through the bloodstream to the kidney. So, box here. The output in this case for the bone, osteoclast on the bone's surface, release calcium stores. And then I'm just going to finish this one out. So osteoclast on the bone surface release calcium stores. And what that does, this is a result of that output. Calcium from bone stores is released into bloodstream. Actually, I'm just not going to label that one. And then another box. I'll just put this one right here. So PTH travels through the bloodstream to the kidney. When it gets to the kidney, we'll call this output, although it's not technically output. Nothing's being released, but we'll call it output anyways. We'll say PTH travels through the bloodstream to the kidney, signals for calcium reabsorption, and this would be within the nephron tubules. You all remember learning about the nephrons and the nephron tubules. That wasn't very long ago at all. Okay, try that. A little arrow there. If you choose to, it's cool if you want to draw it on paper or do it on a different software, but if you choose to use this one, super easy. As you can see, you just click the shape you want to use, you double click into the box to type your text, and you can just insert the little arrows. And like I said, there's plenty of ways you can make it pretty if you want. Okay, I have 2 minutes left. So, PTH travels through the bloodstream to the kidney, signals for calcium reabsorption within the nephron tubules, and something else happens at the kidney as well. Let's see if I can get this looking decent here. Yeah, that'll do. Okay. PTH also, when it reaches the kidneys, synthesizes vitamin D. Okay, I need 2 more boxes. Nope. Okay, I'm running out of time, so I'm just going to pause right here and start a new video. So we'll call the other one part 2. So hold on just a second.